Today we're starting on imaginary numbers. So far, everything that you've dealt with in your life, probably, unless for some reason you took another course somewhere, everything you've dealt with has been real numbers. These are not real, they're imaginary. Notice the section heading is complex numbers, so we're actually going to have a combination of real and imaginary numbers shortly. All right, now, it sounds because you're always used to dealing with real numbers like it's going to be like super complicated. However, it really isn't if you pay attention and you think it through. Okay, an imaginary number is how we handle it when we have a square root of a negative. We can't actually evaluate and get an answer from your calculator for a square root of a negative. However, you'll get an error. Okay, some of you are checking on that. It's good to make sure that I'm telling the truth. If you took the square root of -1, go ahead and verify it, put that in there, and see what happens. What kind of error message you get?
No real ANS.
No real ANS. No real answers. So, if there is no real answer, that must mean, for right now, we have no way to handle that. Now, I want to make this as simple as possible. If we have the square root of -1, giving you a brand new definition. Brand new definition. The square root of -1 is represented by the lowercase letter I. That's what I for imaginary. Square root of -1 is one imaginary unit. And we represent it with an I. Okay? Yes.
Would there be an understood one?
There's an understood one, but you're never going to write it.
Okay.
Okay? So the square root of -1 is one imaginary unit. We represent that with an I. So if I had something like this, if I had the square root of -25, in the past, the best you could do with that was to say no solution or no real solution. Okay, but now we have a way to deal with this. Square root of -25 is really -1 times 25. And that can be broken up. That can be broken up. The square root of -1 is
1.
I.
I.
And how much is the square root of 25?
5.
So this is really 5I. You'll always write the whole number first and then the imaginary part. Yes.
Oh, so that.
Two things. First,
You
the
got
I
that?
is supposed to have like a tail to it. I would say backwards, lowercase j.
I've always seen it written as a script I, and it's hard. You can see it in your book as a script I. I always put the little tail on it because it makes it a little bit easier than if you just write a straight up and down I. Sometimes people will choose that as a variable, but the script I is just how you always see
And
it.
so basically the whole point of it is always to break it down to
Yeah. If there's a negative underneath, you will always break it down so that you have a -1 times the thing, and you can simplify then based on having the two parts. You have the imaginary part, and then you have the real coefficient. This one, there is none, so there's an understood 1 there. If we had something like this, if we had the square root of -12, okay, we know that there is an imaginary part. There's also going to be a real part. There's also going to be a radical in this one. Okay, because this is really, when we break it down, we have a -1, but the 12 can be broken down, right? Because 12 doesn't come out even when you try to square root it. How much does that happen when you factor tree it, break it down?
2, 2, and 3.
2 times 2 times 3.
So
So you have several things going on here.
Mm-hmm.
You wanna deal with what the whole number part you can pull out first. So how much is that? We have 2.
Yeah, that's gonna be 2.
Then you wanna deal with, is there an imaginary part? And
Yeah.
there's an imaginary part, and then you deal with the leftover root.
Whoa.
That's not what I did.
So the correct way to write this would be to sandwich it in between like that. Okay, you will, and part of that is because when you write this root, if you put the imaginary part afterwards, it's sometimes difficult to tell whether you've got the root covering over the I or whether it's separate. So as far as the sequencing goes, theoretically, okay, I don't want to go there yet. Okay, you would put the whole number part first, and then you would put the imaginary part, and then you would put the leftover root. If there's just a root,
You guys are drawing attention. You guys start talking.
okay, if there is just a root left, for example, if I had the square root of -5, there's nothing that can come out of this. So I would write it as, there's the imaginary part, and the square root of 5 comes after.
So the negative drops.
So the negative turns into this imaginary outside the radical.
So that's it.
Okay?
That was
These things, this right here is an imaginary unit, as I said. And these numbers right here are what we call pure imaginary numbers. We will get to complex shortly. Now this only works with the square root. You're not having the 4th root or the 3rd root or anything else in here to get imaginaries. As a matter of fact, you can have a 3rd root of a negative and not have a problem. Okay? So this is strictly based on square root problems. Yes.
If it were other roots, would they be like no solution of it?
If there were other roots,
Like if it was a 4th root, would it be no solution?
oh, you would still be no real solution yet.
Okay.
You would still write no solution, and we would be very good with that. All right, so now what we need to do is we need to think about and analyze and work out what happens when you begin to take an I to a power. Okay?
Power?
When we begin to take an I, an imaginary unit, to a power. So there is a series of 4 that are going to be very, very important to you. So you need to really, really follow along here. First of all, we know that the square root of -1 is I. Okay? Really what that is it is I to the 1st power. So I'm going to put up here in the corner, I to the 1st power is I. Okay? I showed you where it came from.
So that's kind of like our template.
This is going to be a pattern that we actually follow in order to figure these things out. Okay? Now, if I had I squared, okay, I squared, that would be the square root of -1 times the square root of -1, right?
Oh, yes.
Okay?
Oh yeah.
Okay, so the square root of something times itself is how much?
Itself.
Itself, so this would be how much?
Negative.
-1. Alright, so this is what, I mean, it actually also follows this pattern also. So we have I squared has to equal -1. Okay, you're not going to do this work every time. I'm showing you where these different equivalents come from. You need to make sure it's in your notes somewhere where you can see it all the time when you're doing any of these type of problems, because it's that important. So I to the 1st power, or just I, is I. I squared is negative 1. I cubed is really I squared times I, right? That makes sense?
Yeah.
No.
I squared times I, so there's 1, 2, 3 i's, breaks down into 2 of them and another 1. So that's really, how much is I squared?
Negative
Negative 1.
Times negative 1.
And I is I, so this is really
Negative
negative I.
Whoa.
Okay,
Alright,
so
this-
So that'd be
I cubed, when we simplify it, is negative I. You're not going to go through the simplifying process every time, but I wanted you to see, instead of just randomly throwing these things up here,
So we see.
okay, you have to see where they came from. Okay? Alright, so let's try I to the 4th power
I squared and I squared.
is I squared times I squared, right? And how much is each I squared?
Negative 1.
So how much is negative 1 times negative 1?
1.
Regular 1. So I to the 4th power comes out to be 1. Now this set of 4 actually repeats over and over and over again. Okay? This set of 4 is extremely important to you, and we'll see that they repeat. Because here, if I have I to the 5th power, okay? That's really 4 i's and a leftover one, right?
Yeah, so I squared.
I to the 4th, that's meant to be a regular 4. I to the 4th times I, so that's 1 I. Okay, so it's really just I. So it begins to repeat.
Wait, but
Okay.
I thought I to the first would be.
I to the 1st is I. I to the 2nd is negative 1. So really what you're doing when you're simplifying powers of I is you're figuring out whether it's I, negative 1, negative I, or 1. Okay? I'm going to do some more of these out and see if you can figure out a way that might be a shortcut. If this is I to the 6th, what it would be good to get. It would be good to get, well, if we get I cubed and I squared, we're going to make more work for ourselves. You want to get as many groups of 4 because they're just 1. Okay? So it's I to the 4th,
I squared.
I squared. Because here's your 6. So this is how much? How much is I to the 4th? 1. And I squared is negative 1. So whenever you have a group of 4, that turns into a 1. So basically it's gone. It's just a 1 times something. So it's 1 times negative 1. So it's negative 1. So I to the 6th is negative 1.
This.
So you're really trying to bring out as many 4s as you can. So I to the 7th, I to the 4th, I cubed, which gives you negative I.
There's a pattern.
Because the 4s always just turn into 1. So there is a pattern, and really what you can do, it doesn't matter how many groups of 4s that you have. Let's try I to the 13th power.
Oh.
Okay? How many groups of 4 do I have? 3? 3 groups of 4? Now, I'm going to write them out here for the sake of argument so you see it, but I want you to try and figure out a shortcut. There's
Just like
4,
adding each other.
and then how many's left over?
1.
1, so it's I.
I'm just kind of like adding each other.
So really what you're doing Does anybody see a way you could do it without writing all this out? Charles, what are you saying?
So if I to the fourth is always 1, then wouldn't the leftover
Oh.
number just be the answer?
The leftover number will be the answer, and you look on this chart to find out how that simplifies. Yep,
Okay,
Did you just divide the exponent by 4?
that's it.
Oh.
That's
Oh,
what we're
yeah.
going for. He said, can you just divide the exponent by 4? Yes, you can. And I divide that by 4. That gives me 3, and I don't even really care about that. What I care about is this remainder.
Oh, so the remainder is your answer?
The remainder is the exponent. 1, 2, 3, 4.
Well, that's a good trick.
This is the exponent. And then you just read the answer from the chart. So if it's a 1, your answer's I. If it's a 2, your answer's -1. If it's a 3, it's -I. If it's 4, it's 1. So this number is just so that you can make yourself understand. You care about the remainder. Okay? So let's get a crazy one here, just to
To the 25th.
25th. Let's
Yes!
do
Please
that.
no break them.
Oh, never
No,
mind.
75.
Now some of you who aren't used to this dividing method will get you.
I.
Okay, so I the 25th. Okay, we'll take 25, divide it by 4. Even if you did that in your calculator, you would get 6 point something, right?
Yeah.
So you have 6, and then you can multiply these two.
24.
24.
24.
You got one.
1 left, so how much does I to the 25th equal? I.
What?
Because this 1 is your exponent. That's how much is left over that doesn't get into those groups of 4.
This is awesome.
Okay, so it is. It's a really neat trick. How about I to the 283rd power?
Heck no!
What? Divide by 4.
Oh, you are.
All right,
70.
this is not 283.
70 times.
Okay, somebody on your calculator really quick. Just divide that out.
70 with
283.
0.75.
70?
Yeah,
70 with
70?
0.75.
70 is, and how much is 70 times 4?
280.
280.
So there's a remainder of 3. I see what's happening.
Remainder of 3
So I to the 25th equals -I.
is negative,
70.
negative I.
Well, that's so cool.
You just pick it from
It's like a
your
cheat.
chart.
It is
Now, if you
cheating out now.
lose your chart, if you are not keeping good track of where your notes are and your notebook, if you don't have this, you're pretty much sunk. You need to make sure you know where this is in your notebook. If I were you, I might even get one of those little sticky tabs that go on there so that you can always find this. All right? It's important that you be able to find this. See how easy, the method is super, super easy.
Super spooky.
If I hadn't gone through that whole process, though, you'd be going, what? This makes no sense. And, but you divide it out, however much is left over tells you which one of these is your answer. There's only 4 possible answers for a power of I.
That's awesome.
Okay, only 4 possible answers for
I like
a power of I. Good, I'm glad. Good, I'm glad that you like it.
It's like multiple choice.
Yep. All right, so now we're through. Now we're through the introductory part, the imaginary numbers. Now we have to do more things with them.
No!
Okay?
Have a random
Oh, we
face.
really do.
Stop it.
Okay? You're doing good. You stayed with me. Brand new concept. We now know what an imaginary number is. We know the 4 possible answers when you take a power. And we need to move on a little bit. All right, Naomi?
A little bit.
All right, so let's take this one. Let's say we have negative 3i times 8i. Okay? So we want to be able to multiply.
Oh, will that be negative
Okay,
24
so
squared?
for just a quick minute, consider it just as if the i's are regular variables.
So it'd be negative 24.
Negative 24 I squared.
Which would give
Okay.
you
However, you always want to replace this with its simplest form.
So
How much is I squared? Look at your chart.
Negative
negative 1. So 24?
So
Negative 24 times negative
24.
1 and it's 24.
24.
It's a very strange way of writing 24, but that's all it is, it's 24.
Just write 24.
So you go through the simplification process,
Simplification process.
okay? You treat it as if it's a variable, even though it isn't. And then at the end, you replace all those squares and cubes and to the fourths and all those things with a number, okay? Now, here's another thing we have to be extra careful with. If we have a root of a negative, and then we have it multiplied times another root of a negative.
It's a pop.
It's a pound.
Okay, now, there was a little technicality that really you guys probably glossed over, even though I put it up there. And that was, as long as the things underneath were positive, you could put them underneath the same radical. In this one, because there's a negative, we have to be a little more careful. Before we can start gathering up under the same radical, we have to consider, we have to take out the i's. Okay, so here, this one has an I in it. This is really -1 times 6. Before we are allowed to gather them under the same radical, this is a -1 times 10.
So that we.
So this is I times the square root of 6, right? And how much is this one?
I times the square root of 10.
I square root of 10,
Which gives you.
which gives us I squared
Square root of 60.
square root of 60. Now both of those can be simplified, but it's a little bit different than if you had just said 60 underneath, because negative times negative makes positive, because the imaginary numbers, which both of them contain an imaginary unit, you have to be careful with. What does I squared simplify to?
-1.
-1. And square root of 60 can simplify, right? 6 and 10 and
3 and 2.
2 and 3 and 2 and 5. So let's get this taken care of. We have a pair of 2's and we have a 3 and a 5. So 2 comes out. So I have -1 times 2 times the square root of 15. And I've run out of space here. It's -2 square root of 15. Now be very careful. Here's where that whole technicality with the negative comes into play.
Whoa.
You have to bump those i's out. This one, if you just did 6 times 10, you would have had just regular 2 times the square root of 15. Okay, and that would have been incorrect. So you've got to be like super careful on that. Yeah, Luke?
If you were to not bring out the 2, if it was not reducible, would it just be, would you still need the 1, or could you just do like negative square root of 60?
Negative square root of 60. Yeah. So you have to clean up your notation at the end. So you've got this -1 hanging out here. Don't leave it in the actual final answer. You want to make it as simple as possible. Okay? Is everybody still happy with this?
Yeah.
Nope.
Okay. Well,
I'm not happy with math.
you're honest. Okay, but I think you're getting it. Let's do another one. So let's say you have. Okay. Let's move along. Let's try another one. Let's say I take -20 times the square root of -5. -20 times the square root of -5. So what first?
-1 times 20.
-1 times 20. And if you don't write that step, it's okay. If
So
you
it's I.
bring out the I, square root of 20.
Yeah, I
Which should reduce it.
Okay, so go ahead and do that if you need to. And then the other one would be
I square root of 5
I square root of 5.
So
equals I squared.
I squared times the square root of 100,
Which is 10.
10.
which is 10.
So it's
So it's
Negative
10 times
Negative
10.
one.
-1,
Negative 10.
which is -10.
Wait,
Oh!
Very funny looking -10, isn't it?
I get it.
Okay, good. Let's do another one just in case. You got it written down, everybody?
Wait.
Wait, okay.
That's okay.
Alright, let's get another one.
You don't want to use that camera.
Wow.
Look at that.
Alright, can I do that one?
No.
The answer.
I'm gonna do. Second.
John, yeah. Go ahead, John.
No, I'm kidding. No, what's his face can do? I don't know what the heck I'm doing.
I'll do it.
Let Alvin do
Let
it.
him-
Alvin and Anton tag team.
Thank you. Alright, I got the left side.
Okay, alright. Go ahead.
I 35, square root of 35.
I square root of 35.
And then I square root of 7.
I square root of 7.
Man, come on. That's not my fault.
Okay?
So then -1 times.
Okay, so he went ahead and said -1, but I'm going to put in the I squared, and it will be -1, absolutely. Then this one is, you know what I want to do here? This is 35 times 7. I don't even really feel like multiplying them because I'm going to have to factor it in a minute anyway.
It's 75.
So whatever this
7 squares
is 7 times 35, which is 7 times 5.
And that's nothing.
So that is 7 squares.
So I squared 7 square roots of 5, absolutely. So it's 7 and 7 and a 5. So I squared is -1,
Parentheses 7.
7,
Oh, never mind. Not yet.
square root of 5. So
It'll be 7. -7.
square root of 5.
And that's it.
What
And that's
did I
it.
just do?
Okay.
Like, you know,
You did it.
I messed it up. And then that equals.
You can't add unlike terms, but you can multiply them. All right, let's
Don't move it.
Okay, and then I just want to do one other type of problem. Now the danger in all this is that it doesn't give you enough to do the entire whole next homework assignment.
Oh no.
But if you wait until Tuesday, you're going to forget everything. So you need to go through and do what you can do on the next homework assignment, 49. Even, you know, you have the whole weekend, which I know some of you are busy, but you've got Monday, which I know you're finishing your quiz, but finish the quiz and start the assignment anyway.
Tuesday, right?
And Tuesday is when we'll be back again. Let's do this problem right here.
Oh yeah. Those are all.
All right, let's use our algebra to get this thing solved.
Let's not.
Am I right?
So, first step,
Subtract 36.
subtract 36. So far it should look very nice.
I got
4x squared is -36.
Okay.
How is this one?
Divide by 4.
We're gonna have to
Oh
split
yeah,
it.
yeah, I see it. Oh, I see it.
So x squared is -9. So we need to square root both sides, right?
Yep.
Great.
So x equals
Square root of -9.
square root of -9. Preston, what's that do for you?
We're gonna do x equals I
Mm-hmm.
square root of 3.
Square root of 3?
What?
Square root of
Negative-
9, which is
Just 3.
just
Did I say 3?
You
3.
said
You
square
said
root
square
of
root
3.
of 3.
Isn't that what it is? Square.
No.
Oh, square root.
Square root of 9
It's just 3.
3.
is just plain
So you
3.
just basically,
There we go.
so if you do get a
The
negative
answer's
in there, you just gotta solve
Just
for
3
it.
first.
If you get
It's
a
okay.
negative in there, instead of just saying no real solution,
Wait, well, the answer is
we can have, it's 3i. There's no I squared. It doesn't turn into a negative. I if you look at your little chart, it's just I.
John, that's
So 3i is the answer is an appropriate. It is an appropriate answer. Now, we have one little technicality though here. We missed something. We actually missed an answer. Please stay with me. This might be a positive 3i, but it also might be a negative 3i.
So it's a plus
Because
negative.
you're trying to figure out, you're trying to figure out what number times itself would give you -9. It might be 3i. 3i times 3i would give you -9, but so would -3i times -3i.
Oh yeah.
So when you're solving by square roots, you have to keep in mind that there's really two answers hiding in there.
Alright,
Kyle.
we just made this darn complicated.
Yeah.
Well, let's go back and plug it in. 4 times 3i, we'll check them one at a time, squared, plus 36. 4 times 9i squared, plus 36. 4 times 9 is 36, times I squared, which is -1, plus 36. -36 plus 36 is 0.
Wow.
That checks out. You could do the same with -3i. 4 times -3i squared plus 36. Same process. You'd still get, from here on, you'd get the same thing, because this would be 9i squared,
Wait, what?
because -3 times -3 is 9. So this is 4 times 9 times -1 plus 36, which comes out to be -36 plus 36, which is 0. Check. Both of the solutions check. There are really two separate solutions here with a plus minus. Yes. Kyle said, how do you check it? So this is how you check it.
Thanks, Kyle. Thanks.
Plug it back in and make sure it works.
Yeah.